What if we could settle any argument, not with a debate, but with a simple calculation? What if truth itself was something you could actually compute? It sounds like something out of science fiction, right? But this was the incredibly audacious dream of a 17th century philosopher named Gottfried Wilhelm Leibniz. So let's dive into how he tried to make this unbelievable vision a reality. This one quote right here just captures everything about his life's ambition. I mean, just picture it. Two philosophers, instead of shouting at each other for hours, just sit down, take out their pencils, and solve a math problem to find the actual objective answer. Leibniz really believed this wasn't just possible, but that it was the key to freeing all of humanity from endless confusion and conflict. So could we really do that? To get what Leibniz was after, you have to understand the problem that he was completely obsessed with solving. He looked at our everyday language and saw it was just full of vagueness, ambiguity, and all sorts of rhetorical tricks. And he thought that is the root cause of all our misunderstandings. So he asked a pretty radical question. What if we could engineer a perfect language, one that was completely immune to all that confusion? Now, to really understand this vision, you gotta understand the man himself. Gottfried Wilhelm Leibniz wasn't just some philosopher sitting in a chair. No, this guy was a master of law, of mathematics, physics, engineering, you name it. He saw these deep connections everywhere, and he was convinced that the universe, as complex as it is, was at its core totally rational. So his ultimate goal? To literally mechanize reason itself. He knew this was a monumental task, right? So he broke his huge project down into two main parts that had to work together. First, he needed a brand new, absolutely perfect language. And second, he needed an engine, a set of rock-solid rules to actually operate that language. You put them together, and you'd have a system for calculating truth. All right, so let's look at the first piece of this puzzle. Because before you can calculate with ideas, you need a perfect way to write them down, totally free from the messiness of our normal, everyday languages. Leibniz's first big idea was to create a language where symbols didn't represent words, but the concepts themselves. This was going to be a universal system. Anyone from any country could read it, because it would completely bypass spoken language and plug directly into the structure of human thought. And of course, a project this big needed a fancy name. He called it the characteristica universalis. The core idea was to find the absolute fundamental building blocks of all human thought, these primitive or atomic concepts. He figured every complex idea, whether it's justice or gravity or love, was really just a combination of these much simpler, basic ideas. So here's how it would work, step by step. First, you'd have to create this massive dictionary of all the fundamental ideas, what he called the alphabet of human thought. Then, you give each of those simple ideas its own unique symbol. And finally, you create a kind of logical grammar to combine those symbols. If you could do all that, you could, in theory, express any idea imaginable with perfect mathematical clarity. But, a perfect alphabet is pretty useless if you don't have a grammar, right? You need rules for how to actually use it. And that brings us to the second and, honestly, the more radical part of his vision, the engine that would make this whole language come to life. See, Leibniz didn't just want a new way to write down ideas. He wanted a system to process them. He needed a way to manipulate the symbols of his new language to test arguments and figure out new truths almost automatically. He called this engine the calculus ratiocinator, which basically means the calculus of reasoning. Think of it like a formal algebra for thought. An argument would become an equation, and by following the rules of this calculus, you could figure out if a conclusion was true with the same certainty as a math proof. No more debates, just calculation. And this just goes to show you, Leibniz wasn't just thinking about this stuff in the abstract. He was a builder. This machine, his mechanical calculator called the stepped reckoner, was a total marvel for its time. And for Leibniz, this thing was proof of concept. He thought, hey, if we can mechanize arithmetic, why can't we mechanize all of reasoning? It was like a physical piece of his giant abstract dream. His obsession with a universal system of symbols even shaped his most famous invention, calculus. Now, at the same time, Isaac Newton was developing his version of calculus to describe physical things like motion and gravity, but Leibniz came at it from a totally different angle, as a problem of pure logic and notation. The symbols he created, which, by the way, are the ones we still use today, were designed from the ground up for clarity and universal use. It was like a perfect little miniature of his much, much grander project. So, if this idea was so revolutionary, so powerful, why aren't we all speaking in symbols and calculating truth today? Well, as you might have guessed, this incredible, monumental project ran into a few problems. Leibniz himself knew exactly how hard this was going to be. He was totally aware of the challenge. He knew that just discovering that alphabet of human thought, finding all those true primitive concepts, was an almost impossibly difficult task. He once guessed it would take a team of some selected men about 5 years to finish it, which, let's be honest, now seems wildly optimistic. So yeah, spoiler alert, despite working on it for his entire life, Leibniz never actually finished the project. He left behind thousands and thousands of pages of notes, little fragments and sketches, but never a complete working system. And for centuries, a lot of philosophers just dismissed the whole thing as this fascinating but ultimately impossible fantasy. But here is where the story gets really weird. Fast forward to the 20th century, and the legendary logician Kurt Gödel becomes completely obsessed with Leibniz's lost project. He didn't just think it was possible. He thought Leibniz had gotten way further than anyone knew. Gödel actually suspected a kind of conspiracy, that Leibniz's most important work had been deliberately suppressed or hidden away. Now, while there probably wasn't a real conspiracy, Gödel was right about one thing. Leibniz's ideas were way more powerful than anyone realized at the time. They didn't die with him. Instead, they just kind of lay dormant, waiting for the right technology to come along and bring them back to life. And this, right here, brings us to the most important takeaway of this whole story. Leibniz's dream of a universal language and a reasoning calculator wasn't a failure. Not at all. It was a prophecy. It was the philosophical blueprint for the entire computer age, written almost 300 years ahead of its time. Seriously, think about it. Symbolic logic, the absolute bedrock of all computer science, that is a direct descendant of his calculus ratiocinator. The binary system, the ones and zeros that are running on every single device you own right now, Leibniz perfected it and even gave it this deep metaphysical meaning. Artificial intelligence, which is all about trying to formalize reasoning into rules a machine can follow, that's the modern version of his quest. Even modern attempts to build a semantic web, where machines can actually understand the meaning of data, well, they're trying to build his characteristica universalis. So this leaves us with a really fascinating final thought. As we build these ever more sophisticated AIs, ones that can process language and reason with logic, are we, without even realizing it, finally finishing Leibniz's great unfinished work? Are we finally getting to the point where we can just turn to each other and say, let us calculate? The answer is still unfolding right now in the circuits and algorithms that are powering our world.